Hi there. In this video we're going to look at translations. This time we're going to look at combining or composing translations. So doing one translation followed by a second translation. So let's look at our first example here. So we'll just do this brute force first of all to see where we end up. And then we'll have a look at how we can simplify that. And so again, with each of these translations we need to pick ourselves a point. We need to pick ourselves a little ant as we described in last video, because that's going to carry this shape across the page. So let's have a look at this flag A here. There's a little flag, and we're going to translate A by 5 2. So you recall from last video, the top number is how far left and right we go, and the bottom number is how far up and down we go. So it means that this ant needs to go 5 to the right, 1, 2, 3, 4, 5, and then 2 up, 1, 2. So we end up, and I'll leave it red because we're going to translate the ant a second time, but we end up with our ant standing here, and because the ant's carrying this flag, the flag stays in the same position, ends up there. Okay, so that is that first part ticked off. So now we need to translate this answer by 3 negative 6. So we'll do exactly the same process. This top number then tells us that we're going 3 to the right. 1, 2, 3. And this bottom number, now this time it's negative, and you recall that negative means it needs to go down. So it needs to go 6 down. So 1, 2, 3, 4, 5, 6. So our ant, which we'll do as green now because this is where it ends up, this is its image, oh dear, is down there. Actually draw it on the grid square, which means that the flag then is 4 tall from the back of our ant, 1, 2, 3, 4, and goes there and there. So that is the image of A, that's where A has ended up. Now let's have a little bit of a look and see if we can describe this overall transformation. So from the original red ant to this final green ant, if we can describe that overall transformation as a translation. So let's just do some counting here. So to get from this red ant to this green ant, it must have gone 1, 2, oh no, I will do it on the same line. I'm just going to get rid of this so we can count again. I'm going to call it 1, 2, 3, 4, 5, 6, 7, 8 across. So that original red ant has gone 8 across. Again, we'll get rid of these. Counting, we don't need that anymore. So as an overall transformation, that red ant has gone 8 across, and it's gone 1, 2, 3, 4 down, which makes it negative 4. Okay, now that is the overall transformation of 5 2 followed by 3 negative 6. We end up at 8 negative 4. Now if you've not spotted it, just pause the video for a few moments to see if you can figure out how we could have taken these two vectors and written this answer down, written this final vector down without carrying out the two transformations. So pause the video and see if you can spot it. Okay, so if you did spot it, well done. But what we do is we just add these top numbers together. So if we add this 5 and this 3 together, that gives me this 8. And if I add the 2 and the negative 6 together, that gives me the negative 4. And this is what we call vector addition. So if we do translation A, which is a vector, and then another translation, which is a different vector, if we add the top numbers together and add the bottom numbers together, that tells us straight away what the overall transformation is. Let's have a practice with a couple of those questions now. Okay, so we're asked to find the vector that represents a translation of 3, 6 followed by negative 6, 2. So again, we could draw ourselves an ant and actually carry out these translations, but we've got an easier way of doing it. So we do the transformation 3, 6, and then we follow that. So we add on the transformation negative 6, 2, and that's going to give me my overall transformation. So what we need to do, as we saw before, we need to add the top numbers, we need to add the bottom numbers, and that will give us our answer. So 3 plus negative 6 is negative 3, and then 6 plus 2 is 8. So the overall transformation is negative 3, 8. Excellent. Okay, so let's have a look at our final example of this video. So we've got a translation, takes some shape A to some different shape B, and that's given by this vector 1, 2. And then we need to imagine that a second transformation took B onto a final shape C, which we don't know, but we are told that the overall translation that takes A to C is 6, negative 3. And what we're asked to find is that translation B to C. So what we, I suppose, can write is we can say, if we were working this out, that first vector, 1, 2, that's sort of the translation that takes me A to B, plus the vector that takes B to C, has to equal this overall transformation here, 6, negative 3. So I need to think, well, what's got to go in that middle vector to get from 1 to 6 and to get from 2 to negative 3? Now there's a couple of ways we can do this. When we do vectors a little bit more properly in a different video, we'll sort of look at how we can rearrange this. But I think we can just treat this as a filling in the gaps activity at this point. So 1 plus something is 6, and that something has to be 5. And I suppose the way we could figure that out is if we did 6 take away the 1, gives me 5. And then 2 plus something is negative 3. Now to get from 2 to negative 3, I have to go down, I have to take away 5. And again, the other way we could work that out is the negative 3 take away the 2, gives me negative 5. But that is our answer. So again, if you're given the one of the two transformations and the overall transformation, using this vector addition method gives us the tools to find what that missing transformation is as well. Okay, good.